All right, so today we are going to start Unit 1, Topic 1. Students have a brand new note packet and homework packet. Students were reminded that yesterday I passed out a letter that is due on Monday this coming week, dead on Tuesday. The first CFU that we'll be taking of the year is this Friday. If students are absent Friday, excused, they can make it up on Monday next week. There will be 2 homework assignments assigned this week. Homework number 1 and homework number 2. Homework is always collected the first day of the following week. So those 2 homework assignments are both due on Monday. Okay. Next week, I'll be assigning homeworks 3, 4, 5, and 6. All of those will be due on Tuesday the following week. Okay. Homework is only collected the first day of the week, and that's just the pattern I'm going to follow all year. Okay. Now, again, we got a new homework packet, new note packet. The inside cover of the note packet lists every single assignment and due date for this entire unit. I'm expecting to test on September 17th. Okay, so you know now on August 26th that your first major test of the year is going to be on September 17th. Prior to that, you will have 3 other smaller quizzes. The CFUs typically take about 10 to 12 minutes in class, so they're relatively small. Okay. Now, our goal for today is to graph parent functions. I want to do a little demonstration with my graphing calculator so people understand what I'm talking about, and then we're just going to get right into an example. Now, you'll see right away that your ability to be successful in this class, and really any math classroom, is going to be dependent on your ability to do mental math. And I'm going to test that right away. But first, let me give you a little crash course on what the heck is a parent function. All right? Some of you may already kind of recognize this because you would have seen it in Algebra 1. I'll show you the most basic parent function I can think of, y equals x. The most basic function that's tested in Algebra 1. So this is what's called a parent function. Now, if I move it around, if I change it, for example, if I do x plus 3, I move it up 3, the red is not a parent function, it's a transformed function. It's been moved. So the blue is the parent function, red is the transformed function. And I could have also done something like 2x, and now I get something that's a bit steeper. It's going up twice as fast. Again, the blue is the parent function, the red is the transformed. And there's lots of different parent functions out there. In Algebra 2, a really common one is x squared. Okay, that looks like this. And again, if I wanted to transform it, which is actually the first problem we're going to look at, x squared minus 1, the first problem we're going to look at today is x squared minus 1. So that is, the parent function is blue. We're going to create the graph of the red one. It's been moved down 1 unit. And I'll show you one other really common one. We're actually going to see an example of this later today. Absolute value. Okay, that's one that's also pretty common in Algebra 2. It actually creates sort of a V shape. Okay, but we'll see an example of that later on. Okay. All right. So one of the first things I'm going to be assessing this Friday is your ability to understand how to use an equation like this. So all equations, the way they work is they say, if you want to find the value of the function, then what you have to do is take an x value and plug it in. You'll notice that's exactly what happened in this very first line that's pre-printed for you. What they did was they took the number -3 and they plugged it in for x. So the equation is x squared minus 1. Now right here, there's mental math. You have to be able to multiply -3 times -3. Couple rules apply. Negative times negative is positive. 3 times 3 is 9. And 9 minus 1 is 8. Now we're going to repeat that. Go ahead and write that down. We're going to do this with the next value. We're going to take -2. We're going to plug it into the equation. So we're taking and plugging it in for x. Now, can anyone volunteer and help me out with that? What is -2 squared and then subtract 1? Anyone brave enough to do that mental math for me? +3. -2 times -2 is +4. Because again, negative times negative is positive, 2 times 2 is 4, and then you have to subtract 1, you get 3. Okay? Now, I'm going to demonstrate that again with -1. You want to plug in -1. this is what it would look like. You take -1, you square it, you subtract 1 from whatever that is. Okay, -1 squared, that's -1 times -1, which is +1, and 1 minus 1 is 0. Now I'm going to show you how I use colors, and I'm going to do this all year long. If you ever see me write something in blue on the screen, it will always be bold, and that is me saying you should be writing this down. Blue, bold, copy it in your packet. But I don't want to make you write that same stuff over and over and over again with just a different number. That's kind of obnoxious. So now I'll write one more in blue, but the rest I'm just going to write in green. I'm basically telling you, you don't have to write that down if you don't want to, because you're just kind of writing the same thing over and over and over again with a different number. Okay? Now again, every single one of these requires a little bit of mental math. 0 times 0 is 0, minus 1 is -1. 1 times 1 is 1, 1 minus 1 is 0. 2 times 2 is 4, minus 1 is 3. 3 times 3 is 9, minus 1 is 8. So for anyone that had any kind of struggling with the multiplication practice we started class with, I'm already showing you on day 2, really the day 1 of instruction, that if you don't have the ability to do mental math, it's going to hurt you. Which is why I'm going to build this type of practice into every single day, except for test days. Okay? You'll walk in, bell rings, you got 2 minutes, practice your multiplication table. Okay? Now, but we're actually done with this problem. You know, it says the function f of x equals x squared minus 1 is shown below. Complete the table. We've done that. But then it says plot all 7 points on the curve. So that's another Algebra 1 skill I want to make sure we hopefully still have. When you're plotting a point, what you have to do is pay attention to the x value, and you have to pay attention to the f of x value, which is often called the y value. Now, the other thing I want to make sure we're clear on is that when you're plotting a point, the x value tells you how far left and right to go. The f of x value or the y value tells you how far up and down to go. And you always start at the origin. Always start at the origin. You always start right in the middle. Okay? So if I want to plot the point -3, 8, the -3 is telling me go to the left 3. The 8 is telling me to go up 8. So I'm going to take my pencil, and I'm going to start at the origin. I'm going to go left 3 and up 8. I'd like you all to plot a point there. Okay, I probably should have done that highlighting in green. So you don't have to draw the highlight, it's green, but you all need to plot a point at that location. At -3, 8, please add that point. Okay, I'm going to do the next one. Oh, let me ungroup that first. There we go. So now I'm going to plot the point -2, 3. That says go left 2, go up 3. So again, I start at the origin, I go left 2, up 3, and I plot a point right there. Do that now, please, on your own paper. Okay, and I'm just going to continue following this pattern over and over again. For every single point, I'm just going to look at the very first number. In this case, it's a -1. That tells me go left 1. And then I'm going to look at the second number. This is a 0, which actually means don't go up and down at all. A lot of people get confused when they see zeros. They're not really sure what that means to do. But this means go left 1. This means don't go up and down at all. Okay? So I start at the origin. I go left 1. And I do not go up and down at all. I just stop. That's where the point goes. Now the next one takes the exact same numbers, but flips them. Now instead of -1, 0, it's 0, -1. That's a completely different point. That's another thing that a lot of students mess up. They don't really appreciate that -1, 0 is completely different than 0, -1. Okay? So this point says don't go left and right at all. Start at the origin, don't go left and right at all, just go down 1. So I start at the origin, I don't go left and right at all, I just go down 1. So that is a completely different point than what we got a moment ago. Now, the nice thing with all the other examples, we get away from negative. So every single one of these other 3 points that's left, it has a positive for the x, so they all mean go to the right. This says go right 1, right 2, right 3, and they all have a positive value. Well, 0 isn't technically positive, but they don't have any negative values for y. So this y value means don't go up at all. This means go up 3. This means go up 8. Okay, so starting with this one, go to the right 1, up 0. With the next one, go to the right 2, up 3. And with the last one, go right 3, up 8. This is one of the essential skills that I'm going to be assessing this Friday. I want proof that if I give you an equation, you can fill in a table, and then you can transfer that to a graph. Okay, and we're going to practice that a few more times today. All right, so we're going to look at another one here. It says use the function f of x equals 3x minus 1 to complete the table below. Be sure to show your work. Then sketch a graph of the function by first plotting all points from the table. So this problem is exactly like the one we just did with 2 differences. 1, it's a completely different equation. And 2, the picture is not already there for us. But here's what we can do. Today, I'm not giving you graphing calculators, but on pretty much most days, we'll be using a graphing calculator. Okay? But for now, I just wanted you to kind of watch the screen. I can take 3x minus 1, go to my calculator, type in 3x minus 1, and look by hitting the graph key at the thing that I'm trying to create. So this is the thing we're trying to create. Now, the way you do that is just perform the mathematics. Remember, this equation is saying just take the x value and plug it in for x. So they did the first line for you. They took -2, they put in for the x. They figured out, okay, 3 times -2 is -6, and -6 minus 1 is -7. Okay? And we're going to repeat that for the other values. We're going to do that for -1. You plug in -1 for x. So 3 times -1 is -3, minus 1 is -4. We're going to repeat this for 0. We're going to take 0, plug it in for x. 3 times 0, well, 3 times 0 is 0. Anything times 0 is 0. And 0 minus 1 is -1. And again, I'm trying to save your hands a little bit. That's why you're going to see a lot in green here. Okay, I made all of the mathematics there in green, which is my way of saying, again, you don't have to write that down. Because again, it's just a repetitive process. It's the exact same equation over and over and over again. It's just you're either plugging in 1, 2, 3, or 4. Okay? So thank you to those who contributed in that little conversation. We got the table filled in. Now all we have to do is transfer those points to the actual graph. Now again, let me remind you, the x value tells you how far left and right you're supposed to be going. The function value tells you how far up and down you're supposed to be going. So when you look at any one of these points, this is how far left and right I go. This is how far up and down I go. Or in this particular case, the -2 means go to the left 2. The -7 means go down 7. So I'm going to start at the origin. I'm going to go left 2, down 7. Please plot a point there now, folks. -2, -7. For the next point. And please interrupt me or stop me or raise your hand or ask questions if I'm going too fast at any point. That one says go to the left 1, go down 4. This is how every coordinate point works. I don't care if you're taking 2-year Algebra 2 or pre-calculus or AP calculus or AP statistics. If you're plotting a point, you're all doing the same thing. The first number is left right, the second number is up down. If it's negative, then go to the left. If the second number is negative, that means go down. So I'm going to go left 1, down 4, and I'm going to plot a point. Now again, very often I find that students get tripped up when a 0 is involved. So please don't let that trip you up. The 0 being the first number just means don't go left and right at all. That's all that means. Don't go left and right. Just go down 1. So you start at the origin, you don't go left and right, you just go down 1. Now, all of the other remaining points are positives. That makes our life a little bit easier because every single one of these points means go right and then go up. Go right and then go up. Go right and then go up. So with this one, it's right 1 up 2. Then right 2 up 5. That would be this one. Then right 3 up 8. And now I'm once again going to show you all how I purposely use colors. The last point, 4, 11, is off the grid. So I'm going to change to green. 4, 11 would be here. Okay? Now, the reason I switched to green is because I will never require you to graph points that aren't even on the grid. Okay? If it's off the grid, then fine. You can just leave it alone and not even put it. Now, please go ahead and also draw the line. Remember, I started this by saying that's our goal. This is the thing we're trying to create. So we got a bunch of points. Now just connect the dots, folks. And that is the finished product for this problem. All right, here we go. Does anyone recall, and I very purposefully used this term earlier today, anyone recall what those two vertical bars mean? I said it once already this period. Starts with an A. AB. ABS. Oh, come on, folks. I said it once already. Absolute value. Okay, now, before I keep going, let me just make sure we're all clear on what absolute value means, because I think a lot of people think it's really fancy and it's really not. Okay, imagine a number line in the front of the room, and imagine I'm standing at 0. And I'll do this in your view. So -1, -2, -3, -4 going, and 1, 2, 3, 4, 5 going in that direction. Absolute value just means how far are you from 0. So if you have somebody that's standing at 3, the absolute value is 3 because they're 3 away from 0. If you have somebody that's standing back at -8, their absolute value is 8 because they are 8 away from 0. Another way to think about it is ignore if the number is positive or negative. Just tell me what the value of the number is. And your calculator knows this. If you ever type into your calculator absolute value of 7, oh, I don't need a parenthesis. There we go. I'm asking the calculator, how far is 7 from 0? And the calculator will say, well, 7 away. And if I say, well, what about the absolute value of -7? Well, if you're back at -7, you're still 7 units away from 0. So in many ways, it just says ignore the negative. Okay? Now, in this particular problem, we're trying to graph the absolute value of x minus 5. Now, today, I'm not having you all use calculators. I will eventually, we'll use them a lot. Okay? But if you were to graph the function absolute value of x minus 5, and then I hit graph, we can see the thing that we're trying to create. Okay, that's the graph that we're trying to create. And in order to do that, we have to be able to perform the mathematics. Notice only one of those is blue. If you want to copy more, go ahead and copy more. But essentially, all we have to do to use this function is take these x values and plug them in for x. That's all I did. I just said, what is -5 minus 5? Absolute value. What is -1 minus 5? Absolute value. What is 2 minus 5? Absolute value. That's all I'm doing. I'm plugging a number in for x and then finding the absolute value. Okay? Now notice the very first one. -5 minus 5 is -10, but you're taking the absolute value of -10, which would just be 10. Next one, -1 minus 5 is -6, but we're taking the absolute value of -6, so it's just 6. I would actually argue these get a little bit easier as you go on. For example, 2 minus 5, that's -3, but again, you're taking the absolute value, so all I want is 3. And the rest, now you actually don't even get a negative number when you subtract. You've got 5 minus 5, which is 0. You've got 7 minus 5, which is 2. You've got 9 minus 5, which is 4, and you've got 10 minus 5, which is 5. And the absolute value of 0 is 0. The absolute value of 2 is 2. The absolute value of 4 is 4. Okay, so these numbers just kind of take care of themselves. Now again, part of the directions are to actually plot the points. We need to sketch the graph. So our goal is to create this thing. And the way we're going to do that is we're going to remember x values mean left, right. Function values means up, down. So when I'm looking here, this means go left 5, go up 10. So from the origin, I'm going to go left 5 and up 10. And I'm going to plot a point right there. Okay, I'll do one more, but I'm going to give you all a moment to do the other ones yourselves, because I want you to have a chance to prove that you actually know how to plot points without my guidance. So right here, we've got -1, 6. That means starting at the origin, go left 1, go up 6, and plot a point. All right, take a minute and try to finish plotting the rest of the points yourselves. I'll wait. So if you finish plotting these points correctly, you'd have a point at 2, 3, 5, 0, 7, 2, 9, 4, and 10, 5. And that creates the V that we already saw on the screen. Okay? That's how all absolute value functions look. They usually build these V's. All right, so we are done. Now here's the deal. We didn't actually get to this page of the packet. You know, we finished this page. I will include this entire page in the Canvas notes, okay, in case you want that extra practice other than just homework number 1. But your homework based on today's lesson is this page right here. And I already spotted 2 people that finished all of homework number 1. Okay? That is my goal for you all. I want to create a scenario where if you're paying attention in class and you're asking questions, then you should be able to get most of the homework done in class. Okay? Trying to make life convenient for you in that way. All right. That being said, we are done. Thanks for watching. Have a good one.